So good
Can
evening all.
everyone?
Yeah, it is there. Everybody can see that. I hope everybody can see the presentation.
Yes.
Okay. So good evening all. I am Rahila, junior engineer from structural department. Along with me, I have Neha, junior engineer, structural department. We will be handling today's session on the topic preparation of beam column layout. So does anybody know what is beam column layout? You can raise your hands if you know the answer.
Try to get it from that title word, beam column layout preparation. Anyone? Okay. So, as the name indicates, beam column consists of beams and columns. That is, beam column layout consists of beams and columns. So, beams and columns are arranged in such a way that the skeleton of the structure is strong and efficient. So, here I have used the word skeleton, which indicates that this BC framing is that much important for a building, as human skeleton is important for us. So, that much importance should be given to the preparation of the beam column layout. So, preparation of the beam column layout is the first and the foremost step of a structural design, and it is very important for the structural performance of a building and its integrity. So, using this beam column layout, the architect will be drawing the central line drawing and the set out plan. So, using this plan, this is implemented into the site, and in order to mark the position of a column in the site. So, architect will be using our beam column layout for drawing the center line and set out plan, so which will be implemented on the slide for the marking and position of the beam and column. So this layout preparation involves the decision of providing the structural members so that we get a better framing to resist the lateral loads. So positioning of these members are very challenging. This is very challenging to provide each and every structural member for a beam column layout. So this is a challenge that we can overcome or tackle by studying as many structural layouts as possible and try to understand the structural scheme. Site visit also helps you to visualize things better so that you will be able to provide the structural member in its right position. So you can physically see how and where the structural members are provided when you visit a site. So in the screen, you can see structural members or structural components. So next we will be discussing on the structural members. So before that, I have a question for you. What are the major components of a building? Anyone? Anyone? Can anyone answer that?
Columns, beams, slabs.
Okay. Yes. So there are many major components for a building. Out of that, we will be discussing slabs, beams, columns, and foundation. So I'm sure that you have already learned all these in your classes, but still I'm just giving an introduction on this topic. So first of all, slabs. So slab is a flat horizontal plate that is used for covering the building from the above and providing shelter to the inhabitants. So this is a plate element that carries the load primarily by flexure. They usually carry vertical loads. So you can just guess what all loads are coming to the slabs. Yeah, you can guess what loads a slab should take. Anyone? What are the loads
Live
coming to the
load,
slab?
dead
Yes,
loads.
yes. Yeah, live load, dead load, imposed load, etc. are the loads coming to the slab. So these loads will be acting vertically to the slab. So the slab will be carrying all these loads, wind load, earthquake forces, etc. and transfer this to the beams. So slab will be taking up all the loads and transferring to the beams. So in some cases, we will be providing a slab that is set at a depth below our regular or normal floor slab. That is, the slab will be at a depth. Do you know what will be the name for that slab? What will be the name given for that slab which is at a depth below the normal floor slab? It is known as sunken slab or sunk slab. So where will be these type of slabs are provided? Anyone? Where will be we providing the sunken slab? Anyone? Have you heard about this type of slabs, sunken slab? Okay. So sunken slabs are normally provided toilet, bathrooms, and laundry areas. Do you know why? What is the reason for providing these type of slabs there? As I said, these slabs are provided the toilet portion or bathroom portion. So there is a need of pipeline in that portion, in that particular room. So if we provide a slab at a depth, we can utilize that depth or we can utilize that sunken area to place the pipelines and utility vents. So in that depth, we will be placing the pipelines. So after placing the pipelines, we will be putting some PCC or some sand as a filling and making that slab. That is the reason why we are providing the sunken slab. So there is also another purpose for providing sunken slab. Do you know why? Anyone? As I said, sunken slabs are provided at the toilet area or bathroom area. Why these are sunk? Anyone? Okay. So another reason is that suppose if you are providing the sunken slab or the toilet floor slab at the same level of a floor slab. Suppose we are providing the same level. So it's in the toilet area or it's in the bathroom area, there will be a chance of water spilling to the surrounded slab. If we provide the slab at the toilet or bathroom, same as in the level of a floor slab, there will be water spillage over the surrounded area. So if we provide this slab as sunken or little bit set at a depth below the regular slab, the spillage can be avoided. So that's the reason why sunken slabs are provided. Mainly two reasons are there: in order to utilize the space for pipelines and in order to avoid the spillage of water to the surrounding slabs. So next we move on to the next component, that is the beams. So they are the horizontal load bearing members of a framed structure. They carry load from slabs as well as load from the masonry wall and the self-feed. So as I said earlier, slabs will be carrying the loads and transferring it to the beams. So these beams are intended to carry the load from the slab as well as the load from the above masonry wall. So beams are acting as a support for the masonry wall and they will be taking up the external wall load coming to it. So and also the self-feed. So beams may be supported on other beams or may be supported by the columns for the integral which will be forming the integral part of a frame. So as you see in this picture, you can see that green color portion shows the column, indicates the column. So consider C1 and C2, that is a column. There is a red color line, that is the beam. So that beam, considering that particular beam, it has a support, column support on either ends. So such a beam which has a column support on the either ends are known as the primary beam or the main beam. So the next, you can see a black line, which is a beam supported by beams on either ends. So such type of beams are known as the secondary beam. So the main purpose of the main beam is to transmit load to the column, transmit the load from the secondary beam as well as the floor and transmit it to the columns. So the function of a secondary beam is to transfer the load from the floor to the main beam. That is the main function of a primary beam and the secondary beam. So as I said, beams are intended to carry the loads coming above it. That is a wall load. We provide beams for another purpose. Beams are also provided for certain another purpose. That is, it is intended to carry the wall load as well as we provide beams to split the slabs. As you all know, the thickness of the slab is proportional to its dimension. As the dimension increases, the thickness of the slab will also be increasing. So that in order to reduce the thickness, we will be providing the beams in between the slab so that we can split the slab and reduce its dimension. So while reducing its dimension, the thickness can be maintained within the limit. So that's another reason why we provide beams. And also another reason is that to get column type. So if we provide a beam in between columns, there will be a column tie so that it can resist, so that the structure can resist the lateral load. So the next portion is the column. So these are the important structural member of a framed building. They are vertical member which carry load from the beam and the upper columns. So as you can see, the red color portion marked is the column. So it carries the load from the beam and the upper column. So now we have learned a column, a load transfer path. That is, the slab will be carrying the loads, transferring it to the beam. Beam will be carrying the loads and transferring it to the column. So column is the portion that transfer the whole load to the footing. Column will be transferring the whole load to the footing. So that design of the column is more important than design of any other structure in the building. So it is more important. We should give more importance to design of column than the beams and slab. This is because if you consider if one beam or if beams failed in a building. So if a beam failed in a floor, that floor will be collapsed. But consider, suppose if a single column failed. If a single column failed, it will cause the complete or entire collapse of a structure. If beams fail, we will be only losing one floor. But if a single column fails, the complete structure will be collapsed. So the next and last portion, last major component is the foundation. So as you all know, foundation, the main function of a foundation is to transmit the load from the superstructure to the ground. So it is a part of a structural system that supports and anchors the superstructure to the building, to the superstructure of a building. So it transfers the load from the superstructure to the earth. That is the main function of a foundation. So they provide the stability to the structure, and main function of a structure is to transfer the load, and it will be distributing equally to the earth. That is the main function. So this will be avoiding the unequal settlement. The foundation will be transferring the load equally to the earth, so it will be reducing the unequal settlement or preventing unequal settlement. That is the main function of a foundation. So that was the final one. So we have discussed about the major components of a building. So anyone have any doubt? You can just raise your hands and ask if there is a doubt. Hello? So there is no doubt.
I think it
Shall
is
I
clear
ask?
for everyone.
Okay, shall I ask some questions?
Yeah, let's ask some questions to them.
Okay. Leah Maria. Hello.
Hello, ma'am.
Okay. Shall I ask you a question?
Shall I- Yes, ma'am.
Okay. What do you know about sunken slab?
These are the
Or
slabs that are provided below the ground level or the base level.
no? Okay, that's a slab which is below the floor. I mean normal floor level. I will show you the screen. Okay. This is a normal floor level. As you can see here, this is the normal floor level. So these slabs are provided below that floor level, not the ground level. Okay, am I clear?
Yeah.
These are provided below the normal floor level. So what is the reason behind that?
Provide the pipes and all, and also it's provided in the toilet area.
Yes. Okay. These are provided in the toilet area to place the pipelines as well as to avoid. I have also said one more point, the reason behind that. Do you remember?
The water, when the water rises up.
Yeah, this avoids the spillage of water. As I said, these are used in the bathrooms. So there will be water coming from the bathroom, isn't it? So we can avoid the spillage of water to the surrounding floors. Suppose this is a bedroom and this is a toilet. So if the level of this toilet slab and this level is same, surely there will be a water spillage, isn't it?
Yes, ma'am.
Yes. So if we provide it as sunken, the water will be maintained here itself. There will not be any spillage to the surrounding slab. We got it?
Yes, ma'am. Yes.
Oh, okay. So phase one session of this is over. So I'm handing over this to Rahila to take over phase two session. Rahila.
Okay, thank you, Neha. So let's start the topic. Is my screen visible?
Yes, ma'am.
Okay. So let's start with the beam layout. So the first step in a BC layout preparation is to draw the beam. So for that, there are some points that you should keep in mind. The first is to study the architectural plan. So we'll be provided with a architectural floor plan. We should go through the plan um, and note that there are some positions of beams, windows, doors, and all. So we have to um, note the positions of these walls, beams, etc. And also, in some cases, they may provide us with some columns. And um, we have to um, incorporate these columns into the beam layout also. So um, and also we should um, we should note the wall thickness and the position of beams, the type of beams that we can provide, and and the position of toilets, and also okay. So and the next step will be the provide beams for all the uh, supporting wall. Provide beams for supporting walls. So the main aim of providing beam is to support the walls. First and foremost reason why we are providing a beam is to support the walls. So in order to support,
Rahila, you're not audible. I think your audio is not working.
hello,
Yes.
am I audible?
Yes.
Okay. So the next step is to provide beam for all the walls. In I think switching from these screens are making system slow. So I'll just go through with the CAD itself. The Okay. The next step is to provide beams for all the walls. In every cases, it is efficient to provide uh, beams in such a way that the center line of the wall and the beam coincides with each other. But it is not possible for all the positions. For example, in the exterior walls, here we can see that the wall thickness is only 150, but we have to provide a beam of thickness 300, or the width of the beam will be 200 or 300. In that cases, what happens is that if we have to coincide the central line of the wall to the beam, it will make some projections towards out, and we have to avoid that. So in these cases, we will be aligning the outer edge of the wall to the outer edge of the beam. And in other cases, as Neha said earlier, that toilets must be provided with sunken slabs. So in sunken slab cases also, if there is a projection of beam in to the towards inside of the toilet, then we have to provide a notch section in the beam. So section the notch sections will make the beam width lesser than the designed width. So we have to avoid that kind of a beam in beam projection inside the toilet. So in that cases also, the inner side of the wall have to be aligned with the beam edge. So this is how it should be provided for toilet slab. And also there and beam should be provided in such a way that we should reduce the cantilever beams. The cantilever beams should be supported to any nearby beams. So in this case, um, we have provided beams for every walls. Here the wall and the beam is aligned to the center line. But here we can see that we have provided beams for every walls. But the problem is that these two beams are cantilever. We have to make it simply supported beams. So in order to make it simply supported, we can extend any one of these beams. So if I extend this horizontal beam, it will go up to here, and it will create a support in here, and also for this beam there will be a support in here. But if I extend this, it will create a support in here for this beam, and support for this beam in here. And can anybody say which one is more economical, the vertical or horizontal beam? When we consider the economy of the building, which one will be the best to extend? Vertical or horizontal? Consider the extended length. You can see that if I extend this one, it will be extended up to here. If this one is extending, it will only extend it up to here. So the economical solution for this problem is to extend this vertical beam. Only for this particular case, if there is if the length of this extension is much lesser than this one, we will consider extending this beam. We will be handling these cases in more areas than we expect. Here also we have that kind of a issue. Okay, I think it's clear. Okay, so so we have covered all these steps. These are the points that you should keep in mind while drawing a beam layout. I think it's clear. And the last point is was already covered by Neha, that we should avoid long span slabs, because we have to limit the thickness of the slab within a range of 100 to 150. So if the span of the slab is higher, then the thickness of the slab will become more. So in order to avoid that, we will divide those slabs into smaller slabs so that we can reduce the thickness. So these are the points. And next is to next step, we use AutoCAD to draw the beam column layout. So for that, in order to draw a beam, we use multi-line. These are multi-line tool, which is used for drawing multiple parallel lines. So these are the some useful commands that you can use while drawing beam layout. The first one will be the MLST. You can note these commands, or I'll show you how all these commands are used in here. And before that, I'll show you a different plan. This one in here, I have already told you that the center line should be coincide with the center line of the beam. But in some cases, the wall thickness will be same as that of beam. In those cases, we do not have to look into the thickness and aligning beam to the wall. We don't need to do that. But see here, the partition walls, there are the toilet walls are maybe 150, but all the other walls are 200. We can measure that. So when you study the architectural plan, you should note the um, wall thickness also. It's 200. And okay, so moving on to the multi-line command. So the first command is multi-line style. We should style a multi-line in such a way that there is center line, there is upper edge, there is lower edge. There are three lines representing a beam. So for that, MLST is used as a command. When we type MLST, there will be a screen which has three. I have created this one. I'll delete this. Okay, there will only be standard. So if you want a new one, we can add new and give it a name, B300, or you can simply give any name. Okay, so and that then we will there is a window where we will provide the number of lines that we want. Initially, it will be 2, but we have to add one more layer so that it will become a center line. And 3 layer must be provided. So for the second layer, that is for center line, we will provide a different color, a yellow color. And for the other layers, it will be, we'll usually provide a color 8 for the beam. Just type color 8 in here and it will appear in here. So for the top and bottom line, it will be color 8. We have to set these colors to the beam and click OK. Then we can show there is a preview of these lines that we are going to draw. Okay, this is multi-line style, and you can also add more layers so that you will get multiple parallel lines. And next is to next command is the multi-line drawing command. That is ML, just ML and enter. And there you will have these three options where you can select the style, where you can specify the width of the beam, and you can specify where to start. So I'll be, the first step will be the style. I have created a style, and if I know the name, I can just enter the name in here. If I forget or if I don't know which one, I can just enter a question mark in here, and it will give you what all are the styles available in here. So I have created beam 1, so I can copy it from right from here and paste it over this command line. Okay, beam 1, and then click enter. Okay, so here also we can see that the current settings of multi-line is the justification is bottom, scale is 500, style is beam 1. And I need to adjust this value. The width of the beam is indicated by scale. So I want to adjust the scale. So I am going to type the S. And I can enter 200 in here. Then the multi-line thickness will be 200. Multi-line width will be 200. So in justification, there are three options: top, zero, bottom. I'll show you the difference of all these three. So first, I'll be choosing top. You can enter T or just choose T, top. So this is how the top justification is. And next, I'm going to do the center one. For sender, it is Z, that means zero layer. And next will be with justification in bottom. So this is the different. The alignment will be from the bottom side. You'll get the idea when you practice it with uh, a plan. Okay, so this is the different. The same line was there, but I drew it with different justifications. So I got this. So and you will know what you have to use when you draw beam in any plan. So next step is to um, join these kind of corners. So for that we have ml edit. mled is the command. And then we will get a screen like this where we can select any kind of joints. So I have a T over here, four T's, and I have a cross in here. So first I'm selecting a merged cross, and then select the merged cross and select the multi-line. Here the cross is merged, and next is for T's I use merged T, and I select these two. So all the T's are joined, and next is this corner. So for that I use this corner joint. Okay. This is how we draw all the beams from plan. So I'll show you the real example for this. Here we can start it right from any corner. So for this one, I'm using justification top, so that the exterior walls will be aligned to the exterior edge of the beam. Right now, I'm just drawing only for this apartment. I'm not going to draw for the entire. Okay. Here for the toilet, I'm using a justification bottom. So in this case, this beam is here also we have toilet, and here also we have toilet. So in these cases, we have to consider which one is the longer span. So this will be the longer span for notch. This will be much shorter than the other one. So we have to provide in such a way that the notch in here is avoided. So we can extend this into here. Okay. And for the center line, if we know the wall thickness, we can just enter the value. Or we can give an OSNAP override and take the midpoint between 2 points. We will get the midpoint of this one. And we can connect this. So when we complete this one, we can select all these lines by extracting only the multi-lines from this by clicking quick select command and selecting multiple M line and equals select all. This will select all the multi-lines from this plan. And we can move the drawn lines to anywhere we want. And then we can edit it. ML edit, we can use the ML edit command, and we can also in here we can avoid the cantilever beam by extending this to the nearest beam. So that I am ML edit. If we are to do this by lines and offsets, it will take too much time to complete this layout. So it is always advised to use multi-line for drawing beam layout. So these are some cases where we cannot use ML edit. We have to do it by trim or extend method. And if everything is complete, we can explode this layout. So I'll be exploding this one so that it will become, all the lines will become line. Previously it was multi-line, now it is line. We can extend this one to the next beam. So this beam layout is created for this particular plan, and the next step is to um, the next step is column positioning, but I don't think that I will be able to take that in 10 minutes. So we can also there is one more step is there, DXF file creation. So for that, we have to extract the center line from this drawing. For that, we'll quick select from here. We will select the yellow lines only. Lines, we can make the selection as line color with yellow color. So it will select the lines with only yellow color, and we can separate the center line from here. So it will become the beam layout and the center line. And this underline is used for DXF file creation. And for every floors, we will create this type of beam layout, and we will extract this underline from the beam layout. And that center line will be used for creating DXF file. Then later we will export these DXF files into the ETABS so that we will get the beam, column, and slab in directly to the ETABS from AutoCAD. So I'll take that classes in the coming session. If you have any doubts, you can ask right now. So these are the commands used. I have used here. All the other extension, trim, and other tools you may be familiar with. These are the some commands. Maybe some of you are maybe new to this one. Anybody used multi-line before? Adil. Hello.
No, ma'am, I haven't.
Okay. How did you draw the plan for plan in AutoCAD? Okay. If you don't have any doubts, let's wind up this session.
Hello.
Hello.
Anyone has any doubt? So I think we'll wind up the session.
Okay.
Thank you,
Thank you.
Rahila.
Okay. Thank you, Stephen. Thank you, everyone.
Thank you, ma'am.